Hello guys, welcome back to a new video. So let me just change my view. Yep. So today we are going to solve a problem called tapping rainwater. It's a hard problem and it's pretty famous problem and very much asked in interviews. So let me just open this. I already opened this, and yeah, you can see this much of likes for this. Yeah, so given an n non-negative integer representing elevation map where the width of each is 1, compute how much water it can trap. So yeah, so this information is not that relevant. Yeah, but this is the thing. You can see they have shown pictorially, and this is the data. So this the first here is 0th, so the length of the first pole is 0 or bar is 0, so that's why it is not there. Then the second bar is, so bars are in black color, so it is 1. That's why it is shown it here. And then 0, again there is no bar here, so it's 0. And this blue color is water. That is the solution. So just focus on these black bars. That's the given question. So then it's 0, then it's 2 to this 2, and then 1 0 1 3 and blah blah blah. So we have to calculate this contained water inside. So we can, like, we know that, or we can observe that the water that can be contained is one unit here. So this one cube is 1 unit. So here 1 2 3 4 4 cubes, 4 unit of water. So 4 plus 5 and 6, so the total output is 6 here. So 6 units of water is stored. So we don't have to worry about the unit and how much. So we are already given the bar width of each bar is 1. So here the missing bar, that means the width of the water is 1. We have to calculate the height, or we have to find some way to calculate the height. And yeah, so height, and then yeah, so since you know it's a two pointer approach, although it can be solved variously. You can see here it can be solved in various approaches. There is a brute force approach, then there is uh, let me see, there is a dynamic approach, I guess, as well, dynamic programming approach. Yeah, so it can be solved many. So we are directly going to see the main the two pointer approach. Yeah, so I have already copied it here, and also the code is pretty simple. I have already written the code here just to make you understand how the code going to work. Yeah, I'm going to write this code again after we just like understand how it's going to work. So this is the what this happened, just let me redo this, then I click this. Yeah, so this is the low pointer and this is the high pointer. Okay, so that's how I want you to focus on these two pointers. And this is the given height. So first is 0, then this is 1, and the blue color thing I try to make good drawing, although 1 like for this drawing. That is water, and this height of this bar is 0 here, and then 2, and so on and so forth. So in this code you can see there is a variable left max, right max, and the water. So water is the total water we are going to return. We have to return and we have to calculate. Actually these water you can see here is the main output, and these two are, we need these two variables to know what is the left max value and the right max value. So we will see in this how, why it is needed, how we are going to use these. So initially they all are 0, as you can see in the code as well, and also have it written here. So now as you know, I have already tell you in the previous approach, we start the low from 0 and the high is n minus 1, the length, the last element in the array, given array. So yeah, while low is smaller than high. So this is pretty standard, as you have figured out till now. If you watch my previous videos, I have solved all these question there. So all this two pointer approach, I have created a playlist, you can check out my channel. Also consider subscribing. Yeah, so come to this. This is pretty standard, low, while low is smaller than high. Now the main thing is here, what we have to do is we have to check if the low, that is the value at the low pointer, is smaller than the value at the high pointer or not. So there will be two conditions, if and else. If it is smaller or equals to, then we will calculate the left max. So here the height of low is 0 and height of high is 1. So it is smaller, so we will go to this condition, and the left max that is 0, and height of low, that is 0. So left max will again initialize to 0, and then we will calculate the water is left max minus height of low. So left max, you can see, is 0 and height of low is also 0. So the water will then again updated to 0. Okay, and we will not go this else block, so the right value will remain the same. Yeah, so and then what we will do before going, we are just increasing our low pointer. So let me just increase our low pointer. As you can see, I have increased to the next pointer or the next value. So now we will again check. So this, since while loop run for while low is smaller than high, so we again go to this while loop and we will check height of low is smaller than height of high. So height of low is 1 and height of high is also 1, and there is, you can see, there is a equals to sign. So we will go to this condition, left max will get updated. Left max currently is 0 and height of low is 1. So we will update it to the max value of 0 and 1 is 1. So this will be updated to 1. And also water is left max. So left max is 1 minus height of low. Height of low is 1. So left max will be again updated to 1 minus 1, that is 0. Then we will again move our pointer to the next value. You can see low pointer. And then again we will calculate this. Now the low is 0 and high is 1. Again it will go to this if, and the left max will be, in this case, left max currently is 1 and height of low is 0. So it will be max, left max again updated to 1. And water plus equals to left max, that is 1 minus height of low. Left max is 1 and height of low is, you can see, it's 0. So it will be like 1 minus 0, that is 1. So water will be updated to 1. Now you can see this blue thing here, that is water, and you can visualize now water updated to 1 when the pointer is currently here. Similarly, we go to the next pointer. Let me just quickly move to the next pointer. Here it is 2. So now the low is 2 and high is height of low is 2 and high is 1. So it will not go to this condition, it will go to the right max condition. Right max will be then right max currently is 0 and the height of high, that is 1. So let me just change the value accordingly to 1. Okay, and then we will calculate our water, that will be right max, that is 1 minus high is, so it will be 0. So you can see there is no water here, so the water will be added 0 and it will remain same. Yeah, then we will move to the next. Now here it will be the high minus minus, so we will move the pointer. Let me just move the pointer here to this. Now as you can see, this is 2 and this is 2, so they are equal here. So it will go to this block, and then left max will be left max or height of low, that is 2. So max is here 2, I guess. So let me again check. Left max currently is 1 and low is 2. So here it will update it to 2. Now water will be calculated. Left max is 2 and height of low is 2. So it will be, water will be like, so added 0 will be added to the water, then it will remain the same. And as you can see, there is no water here. So let me just move the pointer again. This time this pointer will move, as you can see here. Now the value at low is 1 and value at high is 2, so it is smaller. then same again this flow will occur. So I just don't want to waste your time. You must have wondered now how the algorithm works. So it will calculate all these waters, here, present it here, and yeah, so at the end it will just return 1, 2, 3, 4, 5, and 6. So if you can see here, it's 1, 2, 3, 4, 5, and 6 value. Yeah, so that's how it will return 6 here. So let me just quickly add the code here again. So n will be like this, height of size. Let me check it's working or not. Yes, it's working. Height and int low equals to 0, int high equals to n minus 1. Then we need a left max value, and we need a right max. If I can write, yes, right max value also 0. Then just low is smaller than high. Yeah, also we need water equals to 0, and we have to return the water, calculated water. In this while loop we have to calculate the water, and that will depend on if condition. If height of low is smaller than equals to height of high, then something happens. In other case this happens. Okay, so here what we will do, we will first update our left max, which will be left max of height. What happened? Yes, height, height of low, and then water will be updated plus equals to, that means updated with left max minus height of low. So yeah, similar thing will be calculated for right max. Right max height, height high, and also here we have to do low plus plus. So as you have seen in the previous video, we increase the low plus plus and decrease the high minus minus. So before that we have to calculate our water like this, height, height of high. So yeah, I guess that should be water plus equals to, we have to add the value, not just update the value like this, we have to add. So this will be like this. If you are wondering what we'll do, this will be like this. So we can shortly write it as this. Yeah, let's check if it works or not. Yeah, this is working for this case. Let me submit it and see if it works for other cases as well. Yeah, it's working for other cases as well. Now I have not completed till end. You have to just write down this in a copy, pen, paper, whatever. You can open this as well, and then you have to complete this with your, and see how the water is calculated and how the right thing also works. This is pretty simple. You have to just write it down with your own hand on a paper or pen. Yeah, so that's about this video. Also, let's just quickly calculate the time and the space complexity, which is also necessary. Time complexity and space complexity. Pretty hard to spell this. So yeah, that's O of 1. We are not using any extra space, and this is also, this is O of n, that is we are only going once in element in this array. So this is pretty same for most of these two pointer approaches. Yeah, so and also we are not using any extra space, all are just variables. Yeah, so that's about this time complexity and space complexity about this. So let me just stick here. We solve this problem. Tomorrow we will start with sliding window. I have all these in my playlist. You can directly go to my channel and check out, and also subscribe. You can just search Shubham Chhimpa over YouTube, or just open this YouTube slash Shubham Chhimpa, and you can see all these videos I have uploaded, and also these playlists I have created. You can check all this in this. Yeah, so if you are new to the channel, consider subscribe and also like this video if you like that, really like the video. And I have
Hello
like
guys, welcome back with a new
let me just
video.
close this. Yeah, so I have pretty drawn this hard to explain you this, so I guess one like should I can expect. Yeah, thanks for watching. I will see you in the next video.